Let's go crazy. Let's go shivy. Let's go stupid.
Day 2 of Golang and Dart. Twitch. Twitch 101, baby. Let's see. Good. Why you
I
laughing?
don't know how we have made it this far in this damn life.
Are you sure? Okay. Yeah. Fuck, it still has the same title though. Edit, full. Yeah. Okay.
Yo.
Yo. What's up?
Nothing.
I got a question for you.
What is it?
What are those? Okay. Yeah, so what's the plan for today? Is it the cleanup for
I know what I have to do because I didn't finish what I did yesterday.
What is it that you're supposed to do?
Well, there was two things. I had the HTTP request. I was supposed to make a function out of it, but I was struggling with that because that shit uses the HTTP.client thing.
Mm-hmm.
And I was just trying to get that over to the other file I was getting, and it was just like causing some damage to me. You know what I mean, bro?
I don't know what you mean.
Alright, be like that. Stay like that forever.
So, is that something that you're going to be able to work through?
No. Maybe. We'll see. I don't know, kid.
Huh? Yeah. So,
So I'm what, kid? So I'm what?
So, do you want to go through this now, like to have an idea of what it is that you're supposed to do, or?
Hell yeah, bro. You ready for this?
Yes, sir. Let me see it. Share that screen.
He's about to steal my information about finance. He's gonna steal the no Bitcoin shit I have.
Yeah. This man's about to lose all his money in Bitcoin.
You think it's funny, bro?
Dude, I can't wait till that shit goes to 0, and I'll pick up all of it.
You can laugh right now, but you won't laugh forever. Do not laugh at my work that I was trying.
Kid, when do I ever
Did you
laugh
get
at
that
your
right?
work? Huh? What'd you say?
I'm not showing that file yet. We'll talk about the others first. So this I just did a quick setup of the test. I never got any tests in last night.
Mm-hmm.
But this is the shit I was messing with. Let me show you first. You see this right here?
Yeah.
This is similar in multiple places, right? So this whole thing right here.
The mock HTTP request, yes.
Yeah, so this right here, I was pretty much trying to get it into its function and just use it, right?
Uh-huh.
But guess what?
Uh-huh.
This is how far I got in. Don't.
I didn't
I
laugh,
just
bro. I
kept
didn't
getting
laugh.
errors.
What you say?
Huh? I just kept getting errors. I didn't I was playing to put this into a function, whatever, but I didn't know so when you, it's like, the only thing that came to mind is I was supposed to use void for the function because this doesn't return anything, and then I think that gave me an error, so I didn't do that.
So I got a question for you. Are you still in the phase of testing it out till it works, or do you not know where to go with this?
I was gonna try a couple things, but the hope is low.
So what's the issue?
Tell me something I'm gonna need. Tell me something good to know so I go in the right direction. I'm trying to get this into its own function in Dart, but it's this thing needs a whole bunch of stuff. The async stuff gave me issues. The client stuff I got now finally. But yeah. It's funny, right? Show your viewers this video. Show your viewers this video. Your one viewer.
Good. One thing I could tell you is if you go into
Why are you looking at my test? Setup.
okay, so here's what we're gonna do. Get it functional first, and then we'll worry about the cleanup.
So don't focus on this.
Yes, get it functional, and then we'll turn this stuff into functions for the cleanup, etc.
Sounds good to me, boss.
Sounds good to me, boss.
Sounds good to me, boss.
Yep.
Alright.
Let me know when you're done with this. I'll be doing some more Go stuff.
You'll be doing some what stuff?
Golang.
Oh, alright. Have a go day.
Alright, peace.
Alright, peace.
Alrighty. So, last time we were going over some Go development, some rudimentary stuff, some some beginner level Go. So the goal for today is to continue some of that, get some more knowledge, and see how far we can take it. Yeah. So last exercise mentioned using strings dot join Go. Let's see. Well, it's different from the so let's try to see what's the difference between just concatenating strings and using the join function. It's probably some string dot join versus concat and go away. So they have some benchmarking tests here. Okay. So you can kind of bytes buffer will be like a memory that can be used using bytes.buffer.reset. So string.join is much faster than sprintf, but concatenate is faster than sprintf. But this benchmark buffer is faster than all of them. So what exactly is this? So it looks like this is the benchmark buffer. It says 0 allocations operations. So test data 0, test data 1, test data 2. Let me get this test data from. I'm guessing it's some kind of a variable, but yeah. Let's see what about this one. String Oh, string.join, string builder, benchmarks. Okay, so even okay, so it looks like the string.join is faster than just regular concatenation, and then there's a buffer that's much faster than all of these. So it probably Go's version of Java's string builder. So okay. Now let's go to 1.3, finding duplicate lines, programs for file printing. So, some computation. And we'll show three variants of what I call fire first version of dupe prints each line that appears more than once in the standard output. Preceded by its input, this program introduces a statement in the map data type in the buff file. So this goes over implementing some logic into your Go application. So let's see. So they start out with importing a couple of packages. Let's make a new file. So ls touch touch.go. So we have our .go file, right? And then it looks like they make a couple of imports for the buffer, the formatter for the strings, and then the operating system probably for getting some kind of argument from there. So they have counts, and they use this function make, which I don't know what that does. Buff.io, new scanner with strings. And then we have the for loop for line. As with for, parentheses are never used around the condition. The places are required for value. Making an optional else. And then key value pairs and provide the constant however store true. The key may be any type of type of any of these key strings raw. Any of these key strings are ints. String built-in function make. The string, the built-in function make creates a new empty array map. It has other uses too. So this is what this. So this is one of the built-in functions for the Go programming language. So it looks like it instantiates a new map. So it says it here, make creates a new empty map. It has other uses too. Maps are discussed in length in section 4.3. So it looks like we won't go too much in depth into how exactly this goes along. And each time depth reads the line of input, the line is used as a key into the map. Corresponding value is incremented. The statement count input.text plus is equivalent to use to statement. So you assign the line to input, and then within your map, you counts line is equal to, yeah, so the value in the map, the value of the key, this key the value of this key is incremented, and then that's how they count the duplication. So it's not a problem if the first count result, we see a range based loop, but the order of iteration is not specified as random. So here, looks like this is where it gets the input from the user. We're gonna run it in a bit. I'm just gonna finish understanding what exactly it is doing. So printf has a dozen such conversions which this table is for complete. So this is just for formatting your string. So it has a decimal integer. This is for, so basically when you're going to be printing the string to be formatted, you pass these in to specify which position it takes in the string. So you have this format for decimals, this for integers, hexadecimals, octal, and binary, and then explains the rest here. So floats, booleans, rune, I don't know what that is, Unicode, code point, maybe it's for char, string, quoted, string ABC, ROC, V, any value or its natural format, E, and then a little percent sign, basically the escape character for percent. So new format string dupe one also contains tab T in the new one. It contains such a scope doesn't matter by default. And then some formatting such as log printf user formatting from FMT as those. Okay, so it's basically saying that every time you use some kind of a printing function with f towards the end, they use the formatting. They use the formatting based on these descriptors, and then anywhere that has something like print line uses %v for whatever you put into your string. So let's try to run this program and see what exactly it is that it will output. So package name. So it looks like they first import buff IO. I'm guessing it's some kind of buffer for you to put in the characters, and then you have FMT, which looks like it's a library for formatting your strings or whatever data structure that you want to print onto a output system. Usually right now we're going to be using it in the console. And then they have function main, which is, if you're familiar with C, it's just where your program starts up. So they have the instantiation and assignment of count, and then like we read previously, make is a built-in function within Go, which will create this new map, which is a data structure of type string, which maps to an int. And then we have another instantiation and initialization of the buff IO library, which will take in, you're familiar with Java, we're basically using the operating system's standard input. And we already have, let's see what the issue is. Expected string. So import buff.io, FMT, and OS. So we have our function main, and then we have two initializations. So there is an issue. Package name. Buff.io. What's going on here? Expected string, but found. Oh, I'm using curly braces instead of parentheses because it's a function call, not really a what's it called? Not a function itself. So we're going to replace this with a parenthesis, and then replace this with a close parenthesis, and yeah. So we have buff.io, and then here os.standard input. So we're good for now. Perfect. Now they use a for loop for scanning some kind of input, which is OS standard in. Right, so we have a for loop which input dot scan function, and then for I'm guessing it's for element and input dot scan. You're basically adding one to the key, to the value assigned to the key of input.text. Input.text, right? Plus plus. And now you're going to be checking for each element in the map whether the value of that key is greater than 1. And if it's greater than 1, that means that there's duplication in there. So for line, so line is basically the index, and then n is the element. By the way, I'm following the code printed out there. I'm just writing it out. Try to see if the stuff that I'm writing is actually correct when I try to run it, etc. Instead of just copying and pasting it. So if n being the value, where's range counts? Yes, because counts is a hash map, so basically it's going to give you a key and a value. So if n is greater than 2, meaning that if the value is greater than 1, my fault, that means that there's duplication. So if it's greater than 1, then print out that printf %d is the it's the formatting string that we saw earlier here in the book. It's the formatting string. Where is it? Just saw it earlier. Yeah, it's the formatting. It's the formatting indication for a decimal integer, and then these are the rest of the stuff. The reason why I know a lot of these is because this is very familiar to C. So if you're familiar to C, this is definitely deja vu, because it looks like this shares a lot of its syntax with C. Now we have a problem here. Count input.text plus plus count input.text plus plus input scanf. So what is the issue here? Let's see. Oh, counts, because we don't have a variable called count. It's counts. So now it looks like we have whatever the program has up there, except for the characters I was supposed to put in. So now we're going to pass in n, which is the count, and then line, n, which is the value, the number of occurrences, and line, which is the index of the line. No. Line is the line itself, meaning the value of the string that gets repeated, and then n is the number of occurrences. So we're printing the number of occurrences in the line. This is basically what this should do. Now, if we run this with the terminal command go go and go run go, right? So it's taking a bit. Should print out something, hopefully. Oh, yeah, because it's waiting for the input from scanner. So if we do this, and then we do this, and then we do this, then we put 1, 1, 1, 1. So since we have 4 occurrences there, and then we finish the execution of this, Control D. So Control D, basically what it does is it ends the string of your input. So if you look here, we have 4 and 4D1. I don't know what this is. So 4D1. 4D1. What is this? 4. So it's supposed to print line. It's supposed to print n, which is the 0, 1, 2, 3, right? And then the string 0, 1, 2, 3. I get where this D comes from. Where does this D come from? Let's try this again. So go run, and then we have 1, 2, 3, 1, 2, 3. Let's see, we have A, B, C, A, B, C. So we should have the occurrence of 1, 2, 3, 1, 2, 3, A, B, C. Now let's just have 1, 2, 3 one more time for a third occurrence, and then A, B, C one more time. So we control D, control D. So we have, oh, I think I know what the issue is. What happens is that it prints the control D. So yeah, if I go run and then I just control D, control D. Wait. Where does this D come from? Go run. So 1, 2, 3, 1, 2, 3, 1, 2, 3, right? Enter and then control D. Yeah, I think it has something to do with the program termination. I wonder if I force quit this, what's going to happen? 1, 2, 3, and then control C. Yeah, signal interrupts. 1, 2, 3, 1, 2, 3, 1, 2, 3, and then Q, 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 and then we do this. Yeah, I think it has something to do with how we're interrupting the program. So we get this extra D probably printed out because we press the control D character. I don't know why it's showing up there, but probably because I don't know. We'll look into it afterwards. So we have the value and the number of occurrences printed using a map. And anything with less than 2 occurrences doesn't get printed. And then this basically talks about the formatting. So now let's see what this program is supposed to do. Many programs read either from their standard input as above or from a sequence of named files. The next version of Duke can read from a standard input or handle a list of file names using os.open to open each. So it looks like we're going to provide probably an array of file names and then scan through those files. So if we look here, buff.io, which is the buffer formatter OS, we import these 3 packages, initialization and assignment. So basically we're taking the arguments from the terminal command line, and then if there's more than one file, we're gonna count lines, OS standard and counts. If length count file less than the name counts much else for okay, so I'm kind of lost here. If the length of files is equal to 0, then count the number of lines in standard in. Count lines OS standard in counts. I don't really understand what this means. So let's try to count lines is a function right here. It's not a built-in function. It's a custom function, or one that's built here. So count line length of files equal to if the number of files is equal to 0, then from standard in, we're going to pass in counts. Input is equal to new scanner for input scan. Oh, this is just from, so basically what we're getting, this is turning this, yeah, turning the terminal count line into a function. So if the Go executable is called without any argument, then it's just going to do it from the command line. Else, we're reading it from we're reading from the list of files, right? So this is the index, and then as mentioned, Go is unnamed a variable or something along those lines. Basically, something that we're not going to be using. And then for each file, we're going to open it up. If it's null, then it's a standard error. Else, we're sending the pointer to the file, or the variable to the file. I'm not sure whether it's a pointer, but I think it's a file pointer, to the count line function, and then it closes it, and we print out the number of duplicate lines for each of those files. So for the sake of time, we're probably not going to be going too much in depth over how to do each of these, because we're just going to be skimming over a good amount of what exactly these do, because it's very similar to this. It's just that we're adding an extra flair, which is getting stuff from a file. If there ever comes a time where I actually need to read from the file system, we'll be able to Google it and get some more information on how exactly to do that. So now, function. Now this is basically an explanation of how this works. Let's just go over it to see if the explanation was right. So the function OS open returns two values. The first is the open file. Is an open file, so that is used for subsequent reads in the file scanner. The second result is the open value. And we built an error type. If error is equal to the special built-in, the file was open. So basically, we have an error check here to ensure that the file was open and that there was no issues encountered. The file is read, and when the end of the input is reached, closes the file and releases any resources. On the other hand, if error is not nil, something went wrong. In that case, the error value described. So error handling. It's interesting to keep code simple and readable. So code clarity. Map is a reference of a data structure created by make. When a map is passed to a function receives a copy of the reference. When a change is called to a function, makes the underlying data structure will be available to the caller's map reference too. In our example, the values inserted into counts map are seen in main. Yeah, so basically this is very similar to Java's passing by reference instead of passing by value. So basically, pass by value instead of pass by reference. So basically, we're passing a copy of the reference to our function, and that's what we're going to be using for the modification. And since we're both pointing to the same address, both the original function, right, count lines, and also our counts, they're going to be counts here and counts here are pointing to the same and counts here are pointing to the same map. So they'll be the changes to any of these will be visible to counts, since it's since it passes a copy of the reference, basically Java information. So so the next program demonstrator basically goes standard image package, which we'll use to create a sequence of bitmapped images which encode sequence. Okay, so before we do that, actually, let's see what the was the version of dupe. Okay, let's finish reading this and then do the exercise. I just realized I skipped this by accident. So, the version of dupe operated above the string mode in which input is read and broken into lines is needed. So the principle is by the arbitrary amount of inputs, all things are to read the entire input into memory in one big gulp. Split it into lines, once then populate the line. The following version of dupe 3 operates in that fashion. Introduce function read file, which reads the entire content in the again, we simplified dupe 3 somewhat fresh only with the name of the file and slayer. So basically, this first version of our application or the Go function would read the file content line by line, which would make it more manageable. If you have a large file with 1,000,000 lines, let's say, you'd be able to manage it as a string since it's line by line. Versus this version, it looks like it takes in the whole file. So if your file's too big, it'll probably run out of memory. And so we take the whole file, and then we process that file. So we have the instantiation and initialization, and then we have the file name, and then data IOUtil read file. So if you see the difference here, first off, they use IOUtil instead of buffered IO, because the buffer, I'm guessing that this is what would take the stuff in line by line instead of the whole file. So they take in the whole file, and then once they're done getting the whole file, right? So you have error handling, and then string.split. So since we take in the whole file, we split it on new line character, and then in the new line character we'll count. So it's the same logic as using the map as before. So we're going to increment whatever value is within that hash map. Well, map. They didn't specify whether it's a hash map or like hash map, etc. So yeah, so we increment the associated value, the associated key to that value, and then. So basically, the big difference is processing a whole file versus processing it line by line. So read file returns a byte. Slice that must be converted into a string, so it can be split using strings split. And I'll discuss some other stuff. So okay, so. Read-write method of OS file. Okay, so this basically mentions some level of abstraction where we're trying to abstract these read and write files into higher level functions so that we don't have to worry about the implementation and all that. So modify dupe2 to print the names of all the files in which each duplication lines occur. So modify dupe2 to print the names of all the files in which each duplication line occurs. So basically, here, let's see. So this is dupe2, right? So we wouldn't have to do anything into this count lines function because it's not file style, so we don't need to worry about that. And so here we have for underscore arguments range blah 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 count lines count. So we read our counts. This is going to return the list of counts, which contains, this is going to return all the occurrences of each key, meaning that whether it's one occurrence or 2+ occurrences, we will get them into our hash map or our map data structure. So since we get this into our map data structure, what we could do is counts. since there's a file associated with it, right? We have the file name, which is in, so we have index argument, open argument. So I'm guessing argument, yeah. Else for underscore range files. Yeah, files is the array of file names. So this would be the file name, right? So we have the file name, count lines, f counts. So basically, what we could do is in our count lines function, the brute force way of doing this would basically be to have a double pass through. So basically, the first pass through would be for count lines, right? So we have this huge. Wait. So what's the question? It's basically asking for modified duplicate in the name of all the files in which each duplicate line occurs. Modify dup2 to print the names of all files in which each duplicate line occurs. Modify dup2 to print the names of all files in which each duplicate line occurs. Modify dup2 to print the name of all the files in which each duplicated line occurs. Yeah, so I was overthinking it. This is much simpler than what I had originally thought. So basically, and so we have count lines, right? So this count lines function would basically return a. This count lines function basically is for incrementing the map, right? We use it both in the terminal version of it, the term using standard input from terminal, and we use it for using it for getting input from a file. So since we use it for both, we would probably have a. So we have count line. We would within. We would have a. Let's see. Let's try to have this in here. So we have our function with the. Oh, let's copy it. Copy. Right, so. I wonder if this is going to format it for me. No, it doesn't format it for me. So let's see if we put in the correct imports, so it's going to format it for us. Let's see. No, it doesn't format it for us. Yeah. So it's like we're going to have to do some formatting. Else for. Yeah. Let's see. It still doesn't auto format it. Format it first. So there's something we're missing here. So there's an issue of account is equal to make, yeah, it's because of this line right here. Yep, and then we have final line down here. Yeah, we probably forgot to paste. Yep, okay, perfect. So this should run. So basically they're saying that the second occurrence of this the second occurrence of this string should print out the second occurrence of the string. Well, not any the duplicate occurrences. The duplicate occurrences should be printed out with the file name. So basically, we would need to just a quick and dirty implementation would be to pass in to make a secondary function, right? So we have let me just this inc, and then we have count lines, right? So we have our OS file, right? And then we import buffer. So that's the pointer to the OS file, I'm assuming. Basically, let's say that we have a count, right? So we would pass in the, let's say, the name of name, well, file name. I'm not exactly sure whether you could pass in, whether there's a way to. I'm not exactly sure whether there's a way to extract the name of the file through the pointer. So I'm just gonna do this the quick and dirty way. So now that we have the file name, so here we're just gonna check to make sure if counts so we have input dot text, right, is equal is greater than 1, right? That means that there's a duplication, right? 0 won't throw this off. 0 is less than 1. 1 is not 0 is not greater than 1. 1 is not greater than 1. So basically, we're gonna print out. We're gonna print. No, it's fmt format dot printf. Whatever our format is there, with plus the file name, of course, because I think that's what they're asking for, right? So we have modify dup2 to print the name of all files in which to print the names of all files in which each So this is operating on the assumption that a duplicate is considered the second instance of a string. Yo. Did you send me something?
No.
Why'd you call me, bro? I was in the middle of thinking that. Fucking bitch. This man killed my whole
That sucks. That really does.
Kid, what's up? Why isn't it starting up?
I just need to know if I'm going in the right direction at this point.
Did it start sharing? I still don't see anything.
I sent it again.
But I still don't see anything.
You're lying.
Kid, you could check the stream though. Why would I lie about last night?
He just wants to have one viewer.
But I'm serious though. I still don't like. I don't
I
see
sent
the
it
request.
again.
Better restart your trash Kintosh. Better reset that trash Kintosh right now and send me that request again, please.
Ask me to share the screen.
I thought you said it didn't work.
It doesn't work, but give it a try.
Ask to share screen. Waiting for response from Endinox Rosdani.
I haven't got it. Shh.
Kid.
So are you gonna start the Zoom link or?
yeah. Before you were shitting on Zoom, but now this
I'm
man's
still
asking,
shitting on Zoom.
bro.
Are you crazy?
Kid. You know what you should try to do? Try problem solving out loud. See see how that shit is, bro. It's pretty interesting trying to problem solve out loud. Copy invite link.
Oh my god.
Kid, why are you saying oh my god? Huh?
On that laggy shit.
Yeah? At least it works. Okay? At least it works compared to your trash shit, bro. Turn off my camera real quick. I don't want to. Should have clicked fucking don't admit. Because these guys are
Let me share my screen.
Share it! Security. Share screen. How do I put the default configuration so that it Dude, do you hear the feedback?
That is, mute yourself on Zoom.
Oh. How about now? How about now? Can you hear me?
Can you see my shit?
Can you see my shit?
This is the horse manure I've made.
Does it work?
I haven't tried it yet. I'm asking if I'm going the right direction. So I got the driver stuff, right?
Mm-hmm.
Like how we have in Connect, right?
Mm-hmm.
I have the two things. I have the correct imports, I believe. Now I'm making my two tests. I'm setting what's it called, to Wi-Fi, right?
Mm-hmm.
When it's on Wi-Fi, it's gonna expect the check icon, which I have here, right? And then it's gonna expect the connected text as well, which I have here.
Before we yeah. Sorry, go ahead.
Thank you for interrupting. And the same thing here. For unknown, I have that. Well, this I'll change, but for invalid. Well, yeah, they're gonna have the same icon for both unknown and invalid.
Mm-hmm.
So I just want to know if I'm going in the right direction with this. I don't know. I'm assuming like this should be fine, but I don't know.
No, because you see, actually, now that I think about it, do you have the mock response set up for when it's on Wi-Fi?
I don't think so. I haven't touched any mock stuff yet. I don't see any mock stuff in here.
What do you mean?
Like in the Connect test, in the Connect driver test, for the Connect page.
Mm-hmm.
I don't see. Like, what are you talking about? Because I'm expecting for it to be similar, right?
This one is gonna have. So what's gonna happen is that when we are not connected, right?
Oh wait, I'm dumb. It's gonna show the mural name for valid.
Yeah. So
I already removed that.
this is it looks like it's gonna have to be set up for the feed page. Yeah. So
So this is invalid.
Wait. Well,
Is it not connected valid at least?
wait. In the driver requested data, right? I don't even think we have stats for unknown and invalid.
Really?
Because if you look into connect.dart, not go into connectivity handler. So you see here we have mobile, Wi-Fi, and none.
Oh.
So and when you're gonna be testing unknown, right?
It's gonna be mobile.
It's not.
Or it could be Wi-Fi.
Yeah, it's not gonna be mobile. It's gonna be Wi-Fi. Both mobile and none are gonna return X, and then Wi-Fi may return valid or unknown, right?
Yep, that makes sense.
So what I would suggest is to have the mock response return a valid response, and then just test for mobile and then test for valid, rather than testing for unknown, because we've already tested unknown for the connectivity page. And even if the status is unknown, we know that we have the same logic in there for no, actually we're gonna need to test for unknown. How do we make it so that the mock response? Nah, because we tested in the actual widget stuff, right? Well, let me see the widget test instead of the driver test. Not connect. The feed. Do we test for unknown?
Invalid. And then connected.
But do we test for unknown?
I don't see that. Yeah, I don't see that.
Wait. Yes, I think that we do, because connectivity result and connectivity dot values. Connectivity result dot value add result. Yes, we do, because we test for Wi-Fi, non-Wi-Fi. We test for Wi-Fi and non-Wi-Fi. And then the reason why we test for unknown is because we don't get a response from the server. So we do test for unknown. Now for the driver test, what we're gonna do is we're just gonna be setting up a mock response so that it returns a valid mural name, right? And then we're gonna be testing one with none. That make sense? Let me write it on the issue.
So I'm gonna make a mock something connected.
Yes, you'll need a mock. You'll need to. You see just how we have mock responses for a valid response, right? Where it says when client.get.
Yeah.
So you're gonna need to make one of those for the driver. And that's gonna be set up on the setup page. So I see that you still don't have a setup page. The way that the driver tests work, if you see each of them, there's one for, you see how navigation, there's navigation.dart and then there's navigation_test, right?
I need this, right? I'm gonna need a feed.dart.
Yeah, you're gonna need a feed.dart, and then that's in the set. That's where you're gonna be setting it up so that the mock response is the HTTP response with the mural name.
Wonderful, Fruity. Wonderful.
Yes, sir. Let me put it up in the issue. So.
Wonderful.
So.
This one's a niche Flutter.
course. Right, but I trust in you, and you can put this.
You trusted in the wrong mother truck.
Driver test validates.
Testing is my specialty now.
Wi-Fi valid source Okay, yeah, so the driver test is going to include one for Wi-Fi with a valid response and one for either mobile or none with the invalid response. So you technically have one of them done, which is the one where you check for when you set the status to mobile or none, right? That's one test. And now the second one is going to be setting it up so that it responds with.
That's for the valid, right?
Yep.
And the valid is the deadliest test.
It's not deadly. You can want to say it's deadly. You see, if you had done it the first time, you wouldn't have seen that it's deadly. That's why it's usually good to get it done the first time. So. Just
need me to do all the tests for you, so I can become a champion.
Amen.
In this life. It's beautiful.
Good. I can tell you that you got this. Okay. So.
You know the funny thing about saying to anyone you got anything when you got this? It's like all the pressure off you. It's like go deal with it.
Nah, bro. I trust in you.
You got it.
I trust in you to figure this out.
I will do my best.
Okay, good. You got anything else for me?
Cells I got.
What's up? use the last two. Use the last
there might be a
two.
whole bunch of brain cells, but 3 are focusing. And those 3 will. The other ones are in dark depths. The ones that are here focusing, I'll tell them they got it.
Good.
Alright,
good. Just do some powder, bro.
You're a the 3 soldiers are pushing through, but the other 1,000,000 have deceased.
Kid, you got this, kid.
Oh, I love this money. The casino didn't help at all.
I don't know what you were expecting to get out of that casino, bro. That's why I said let's go to the mall so that we could see some people. But this man said let's go to the casino, bro.
I'm never going to the casino again.
That's why I was telling you, let's go to the mall. This man, no one's buying anything. You think we're going to the mall?
I should have invested my $60.
You would have been green. You would have been. Your brother's green right now, cause he bought in at 17. So
he's green $4.
He's still green. Okay, are you green for that shit? I did.
Oh,
I did.
God. I'm never playing the casino. The casino's a scam. You never play the casino. It's fun, but it's whatever.
Yeah. Freaking gamble. Probably gamble that stuff in the stock market. Bro.
Never gambling casino shit again.
Good,
at least in the stock market I have a chance.
You got more from NBEV.
I did get more from NBEV. I made $100 on NBEV.
Good, so.
Alright. Might grab some food though. Or like not food, I might grab like some sort of like snack or something.
Always eating, bro.
Okay. Oh, my gym gains are down the drain. I need to I need to eat.
I got you, bitch.
I did. And I'm gonna continue with my mock course move. Hopefully I can have a valid test today that'll bring me some dopamine. I kid. Bye.
All right, now back to problem solving. Where is this damn book? Yeah, so modify dup2 to print the names of all files in which each duplicate. I'm still trying to understand what this question is asking for. It's saying modify dup2 to print the names of all files in which each duplicate line occurs. So print all files in which each duplicate line occurs. So are we just printing if we're just printing the files in which each duplicate line occurs? So mod dup2 to print the names of all files in which each duplicate line occurs. Modify dup2 to print the names of all files. I'm not understanding this. In which each duplicate line occurs. In which each duplicate line occurs. In which each duplicated line occurs. So modify dup2 to print the names of all the files in which each duplicated line occurs. In which each duplicated line occurs. In which each duplicated line occurs. So my guess, well, my assumption is that it's asking for printing the names of all files in which each duplicated line occurs. I don't understand this. Modify dup2 to print the names of all files in which each duplicate line occurs. Modify dup2 to print the names of all files in which each duplicated line. So print out the names of all the files where there's a duplicate line, in which each duplicate line occurs, in which each duplicate line occurs, in which each duplicated line occurs, in which each duplicated line occurs. The names of all files in which each duplicated line occurs. Modify dup2 to print the name of all files in which each duplicated line occurs. Modify dup2 to print the names of all files in which each duplicated line occurs. Which each Modify dup2 to print the names of all the files in which each duplicated line occurs. Modify dup2 to print the names of all the files in which each duplicate line occurs. So I'm still trying to understand what exactly this question is asking for. Is it asking to print the name of the files where there's duplicates, or is it asking to print the name of the files where which each duplicate line occurs? So I'm guessing that we want to print the name of the files in which the duplicate has occurred. Modify dup2 to print the names of all files in which each duplicated line. Modify dup2 to print the names of all files in which each duplicated line occurs. So my assumption is that it's asking for printing the name of the files for each line. So instead of printing an occurrence, we're going to be printing, oh, okay, so that makes sense now. So instead of printing an occurrence, basically what we're going to be doing is we're going to be printing the file name. That's what I'm assuming. So basically, where we had an integer before, modify dup2 to print the names of all the files in which each duplicated line occurs. Yeah, I'm not sure I understand what this is asking for. Modify dup2 to print the names of all the files in which each duplicated line occurs. The names of all files in which each duplicated line occurs. 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 I still don't understand this. It's saying modify dup2 to print the names of all files in which each duplicated line occurs. Okay, so here's my take on this. It's basically each duplicated line, instead of printing out the number of occurrences, we're going to print out where the occurrence happened. So basically, for each duplicate occurrence, right, print the file names instead of number of occurrences. Okay. So that's my assumption. Okay, let me just comment this out for now. So for each duplicate occurrence, print the file name instead of number of occurrences, because it's asking to print all the names of files in which each duplicated line occurs. In which each duplicated line occurs. This is, I don't know why this is so hard for me to understand. Like, I'm trying to understand the sense of this question. Modify dep2 to print the names of all the files in which each duplicated line all the files in which each duplicated line occurs. All the files in which each duplicated line occurs. In which each duplicated line occurs. In which each duplicated line occurs. In which each duplicated line. Print the names of all files in which each duplicated lines occur. So for each duplicate occurrence, append the file name instead of occurrences. So basically what we're going to be doing is for each, when we first find it, we're going to create a okay, so I see how this is going to go. So instead of so basically here's how we're going to approach it, right? So before, what we were doing, if you see in this function above, is that we would take in the key, we would take in the string as a key, and then we would increment the value associated with it. But now what we're going to do is, at the first instance, right? So basically now what we're going to do is for first instance, right? We'll append. First of all, we'll have a map of string to string instead of string to end. So basically what that's going to allow us to do is, instead of having the counts, we're going to have the instead of having the counts, we're gonna have the instead of having the counts, we're gonna have the string mentioning where this string is duplicated. So basically, for the first instance, we'll create a string. We'll add duplicate duplicates found in, right? Duplicates found in as entries value, right? For instances containing string above, duplicate string, right? What we're going to do is we're going to append the file name. So basically what that's going to do is that's going to allow us to have duplicates found in whatever file names that we want to put in. So the first instance would be duplicates found in, and then the second instance would append duplicates found in, and then we'd have the file name. So basically what this would translate to is so basically we have our string first, right, where it's duplicate. Let's just have this string available. Yeah, let's just put it in the function for now. So duplicate string start. Right. We'll just call it that for now. Initialize it to duplicates found in, right? So that's going to be the start of our string, right? And then for each input, we will, for the first instance, we'll add duplicate found in. So basically for input.scan, right? So I wonder if it's null, the first instance. Is n go, assuming that the n go map is string to string null for first entry. Assuming it's going to be null. Let's see. Map value type. So we have the map here. So what's the initial value of exploiting 0 values? So if visited n is not equal nil. Yeah, so I'm guessing it's going to be nil, right? Initial value of map, go. The default 0 value of map is nil. Perfect. So we have our null value. So basically, if our entry counts input dot text is nil, right? Let's see how they check for null in this. If it's nil, if it's nil, right? Then we will set this value to is equal to our duplicate start string, right? Else we will append, because if it's not null, that means that there's another instance of it. So counts, probably change this variable name to instances or something along those lines. Counts counts input dot text is equal to, well, plus equal or dot join. Let's just do plus equal for now. Plus equal file name plus, and then we'll have a space in there for separation. Let's see what the error is. Equal. I wonder if we could do no. Is there like a method like is empty if counts dot is not? Let's see. Checking null string dart. Not no go. Okay. Checking how to check null string and go. You can use a pointer string to map to null. I'm wondering if the initial value of a string, what is initial value of string in Dart? Yeah, so the default value will be null. The default, fuck, why do I keep on looking for Dart? Here we go. Variable declared without an explicit initial value or set to, for strings. Okay, so it's an empty string. Okay. So if this is equal to an empty string, we should be, okay, so if it's an empty string, then we will add the duplicate string start. Else, we're gonna append file name plus a space so that it could put spaces between the files. So count lines 2. I'm just going to leave that back just for testing. So count. So we use this in right here, and then we'll pass in we'll pass in the file name, which is file, no, it's not files. It's arg. So we have the file name. We have a map. Yeah, this is expecting something else. So let's just make a new map here. Counts is equal to a map of string to string. And then let's just call that instances. Instances. We'll just pass that in. Instances. So we have instances, right? Now, for line, so here we use counts. For this right here, for file, so we count lines after we count lines. That's when we do all this stuff. So we have instances, right? So let's just print both of them out for now because we're trying to get this going for testing purposes. So let's just leave this for now. So count lines 2, and then we'll just have the duplicate instance here. I know that this is very dirty, but we're trying to just get it working, and then we'll worry about line. This is gonna be file occurrences. File occurrence. If file occurrence does not equal, and then we're going to need that string not there duplicate. We should probably put it as a higher. I wonder if we could just put it as a higher level function here. No, we can't. Blah, 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 blah. So we can't pass it in as a higher level. So use object-oriented programming that I'm forgetting. Defining constants in Dart. Defining package constants in Dart. My goodness, why do I keep on looking up Dart in Golang? Defining I don't get why I'm not able to use it here. Let's see what the issue is. Non-declaration statement outside of the function body. Let's try const. No. Okay. Const duplicate blah blah blah. So we will be able to use it right here. Duplicate string start. Right. Yep. And now for line file occurrence. So here, this is going to be percent 2% s's. Replace it with %s. And now here, instead, we're gonna say line, and then duplication, so file occurrence, since that's what it maps to. So now let's make a couple of files. Well, this is the compiled version, so let's make a file here. Right, so we have a file, let's call it dup, right, and then we'll have 1, 2, 3, 2, 3, 4, 4, 3, 4, 5, right? And then we'll have dup2, which will have 1, 2, 3. Oh shit! Insert. I don't know why I did that. Oh yeah, because I accidentally 1, 2, 3. But we have 1, 2, 3. So if we take in those two files in our program, it should print out saying that dup2 has a second occurrence. So if we do dup well, go run dup.go, and then we run dup and dup2, it did not show anything. Let's see what we did. Ha 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 ha. Wow, nothing. Let's try to start some debugging. fmt.print line. Am I running the right thing? Yeah, I should be running the right thing. Oh no. In file. So. I see what no. Yeah, os.file for input scan else. And now if our file occurrence, but even then it should have printed out something. File occurrence does not equal change word duplicate string start. Wrong thing. Which one is it? Instances. Okay. Now this should give us something different. Okay, perfect. End file search, duplicate found in dup2. Perfect. Oh. So if we have a second duplication, it should say duplicate finder dup2 So yeah. So we have a functional program. Let's see how we make it so that it doesn't show. So basically, to go over this one more time, so basically what we do is we check if there's something within the arguments. We check to see that we're able to open up these files, and then we go into count the lines. Well, it's supposed to be count instances. We'll find that after, and then we have our input, which is equal to the scanner for the files. So we scan both dup and dup2, which stands for duplicate, and then we have a map of string to string. So if we have our first occurrence of the text, so basically throughout the scan, we check to see if the line is if there's an instance of the line in our map, which is done right here. So if counts input.text is null, that means that there's not an instance yet. If there's not an instance yet, then we're gonna put our duplicate string start, right? But if there is an instance, we're just gonna append that we have a duplicate in we have a duplicate for this line, and the duplicate is contained in this file name. So right now, if there's multiple duplicates in the same file, it's going to print out the file multiple times. One way that we could avoid having the duplication in files is to check to make sure that the file name isn't already contained in the string, which the string maps to. That would cause for probably a linear search, because we would have to check to make sure that there's no occurrence of that string. We could make this like more so that it doesn't have duplication, but right now the goal is to just print all the files that have the occurrence, so we'll just leave it at that for now. So yeah, this is very dirty, but it gets the job done for now. Okay, so to print out the name of all the files in which duplicate line occurs. Or what we could do is, in order to have one pass through, is basically we type in everything. So we have dup2, and then we have some form of post processing where we go through the file once, and we basically have a set of all the names, and then we print out that set. So that's besides the point. Okay, so the next program should I use goes standard image package. We'll use it to create a sequence of bitmapped images. And then encode the sequence and GIF animation. The images are called blah 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 blah. So this goes into more in depth. Go more in depth. Go. So this talks about the. I'm not too interested in this because we're basically going to be using Go for our HTTP server, so I'm going to go into the fetch URL part. For many applications to access information from the internet as an important access, the internet is an important access to the local file. Okay, for many applications, access to information from the internet is as important as access to the local file system. Go provides a collection of packages, groups on the net. Makes it easy to send and receive information to the internet. Make mobile network connections, set up servers for which Go is the feature are particularly useful. Okay. To illustrate the minimum necessary, here's a simple program that fetches the content, the specified URL, and prints the uninterpreted text. This is inspired by the invaluable tool curl. Obviously, when we usually do more. Okay. So this is a demonstration of a fetch using Go's provided library. So let's have our new file. Let's call it fetch. Fetch.go. Right, that's what they called it here. So just call it that, and then it looks like they use a. So it's from a list of arguments. So basically, you have a list of URLs that you pass in. So response error, if for a list of URLs from the arguments, if there's an error, then oh, what's that exit one? I don't know why it would exit, but yeah. So get the response. B is equal to IO read all response dot body. So we take the response and then we process that, and then response dot body dot close. If error does not equal nil, so it looks like we use the same instance of error here. Error does not equal nil, fmt blah blah blah, then this is where we're going to print the body. So this program introduces functions from two packages, net HTTP, fire util, the HTTP get function makes an HTTP request and fails. There's no error, returns the result, and the response is show response. The body of the field of the response contains the server response as a readable string. Next IO util read all reads the entire response. The result is stored to be the body. String is closed, avoiding making resource, resources. And def writes the response as standard output. So I guess that this is where they get into Go routines more. From the high level stuff that I've been reading, it said that this is where Go shines in the concurrency space of fetching a bunch of stuff. So yeah. So since we're getting into a new space, which is HTTP requests fetching URL. This is the fetch request that we're going to be working on. We're going to be taking a quick 13-minute break till around 8:20. So I'll be right back. Let me set up a BRB screen. YouTube. Supposed to use this, so I'm not going to use this. So I'll just use this for now. All right. BRB. Just realized that the audio was out this whole time. Okay. Time to get back to making HTTP requests. Okay. So we have this function. Just copy and paste it over. And then let's just format it. See if we save it, it's gonna know it doesn't format. So okay. Let's go to RAS. Maybe it's no. Okay. Perfect. Okay. Well, we're almost there at least. Let's see what's the issue now. Oh, it's because they're the same package. So if let's just change this to so what is the issue here? I don't get it. Why didn't this give an error? Well, whatever. All we need is this to work either way. So we have our main, and it's gonna take what looks to be a list of URLs, and then make a GET request to that URL, and print if there's an error. And this is gonna be the body. Close. If error is not equal no, and then we're going to print the body. So let's try this. Let's try to run this with Google. So let's do go run fetch. Go run fetch.go google.com. Let's see if this works. I think that I'm supposed to probably put in the HTTPS stuff. So google.com, let's copy its URL, www.google.com, so let's get this, and let's try it. Yep, so we're able to, yeah, I think that this is the HTTP, the HTML for Google, so yeah. Let's see if we can find some other HTML that's simpler. Simple, so if I open up this and then just look up a simple HTML page, let me just find HTML page. See, free code camp has a simple HTML page. Yeah, well, I mean, okay, so it looks like it's a couple of buttons. Let's make this request. Just see what that's going to look like. Ugh. See what we get for YouTube. So if we do www.youtube, yeah, we get a lot. Let's see, it's like some JSON. Yeah, it's a lot of JSON, yep. And then you get some JavaScript in there too. So let's just go on the regular free code camp page to see what that's going to return. So basically what we're looking at right now is the raw HTML of our application. This is basically what gets translated into beautiful into the beautiful stuff that you see on the web browser. So to anyone who's familiar with HTML, wow, I think this froze. Wow, this thing good. I think this just crashed. Yeah, I don't know why this would crash. Let's reopen this. Let's try to read it, see what happens. Oh, command is next. I don't know why this crashed when we made that HTTP request, but basically this makes the HTTP requests to our provided URL. And so it mentions it right here, the HTTP get function makes an HTTP request. There's no error, it returns the result. The response struck rest, the body field rest contains the server response as a readable string. Read all is the entire response resulting stored into B. The body is closed, avoid leaking resources and content. Writes the response in the standard output. The HTTP request fails. The report. So it's going to return something like message host. The function called the io.copy destination source reads from source and writes the destination using instead of io. Later response body into stdio without requiring a buffer large enough. Hold the entire string. You share check. Yeah, resulting in that. Yeah, so this is where they get into fetching using Go routines. So channel equal make chan string. One of the most interesting and novel aspects of Go is, I suppose, concurrent. So for now, we're just gonna taste of Go's main concurrency mechanism, Go routines and channels. The next program fetch hold is the same. fetch for a URL. Content as the previous, but it fetches many URLs all concurrently, so that the process will take longer than the longest fetch, rather than the single one fetches. The version of fetch all describes the response but reports the size and elapsed time for each one. So we make a channel for go fetch. So from that channel, for range OS for FMT, receive from the channel FMT time since start of 8 seconds from fetch. Yeah, so basically this is the concurrent support of fetch go routine. So a go routine is a concurrent function execution. A channel is a communication mechanism that allows one go routine to pass a value to a specified type. Pass a value in a specified type to another go routine. Function main runs in a go routine, and go sender creates additional go routines. The main function creates a channel. So of strings usually make fresh statement on the first range. Starts the new go routine, small slash use parentheses, fetch all the URLs and use the body reports and describes the vulnerability. When one go routine attempts to send a receive, it's blocked until another go routine attempts to correspond by which point the evaluation is good. In both go routines proceed. Yeah. So this goes over what a web server would look like in Go. Yeah, so this is basically a quick start to Go. So we have our web server code right here, HTTP handle. So this is the home handler. Right, so I click on. Accessing the HTTP server from the server has two members. Yeah, so this is basically going over loggers and all this stuff. Okay, so this basically goes over the other main types of things to find in Go. Well, basically most programming languages. So it says here name type. A type declaration makes it possible to give a name to an existing type. Since struct types are often used, often long, they are nearly always name familiar. Example of this definition is a point. So you have a point which holds an x and a y. The point type declaration. In types covered in chapter 2, we have pointers provide. Go provides pointers, very familiar in C. If you're familiar with C, you'll get an idea of how Go works. Values that contain addressing a variable. In some languages, know that C. Pointers are relatively efficient. In other languages, pointers are disguised as references, and there is not much that can be done to this pass through them. So this is something like Java, Python, and probably a lot of those object-oriented programming languages. Well, maybe not C++ because I don't know they let you do all that stuff. Go takes the position somewhere in the middle. Pointers are explicitly visible. The end operation yields the address of the variable, and the start operation retrieves the variable. And the pointer that refers to, but there's no pointer arithmetic. Okay, it says that we'll get into more details later on. So, methods and interfaces. A method is a function associated with the name. Go type. Go is usually that method. Maybe attached to almost methods are covered in. Oh, I thought that this one all for methods, but we'll see what exactly it is that they're talking about when they're mentioning methods. So Go comes with an extensive standard library. This packages that can be generally programmers often. That's a good idea. Yeah, so this is to go with the pre-existing packages in Golang. So IO, math, prime, net, HTTP, RPC, OS, exec, signal, user path, and time, text, time, other packages, and also the name of your unreleased compatibility requirements. So what we get. Debug, image, net, review. Okay, so we already mentioned implementation. Okay, so program structure. We finally get into some more interesting aspect instead of some quick and dirty stuff. So now it says in Go and one builds basic structures, random storage, simple expressions, that combines larger ones, operation. Basically, this is mentioning that smaller elements make up bigger elements, like data structures, etc., and then that's how we're gonna build it up for bigger stuff. So name, the name is go for name begins with a letter. Underscore, and may have a number of additional letters, digits, and underscores. Case, heap, sort, and heap sort are different names. Go has 25 keywords, so this is just like most programming languages. True, false are reserved, and then a bunch of other stuff. So, in addition, there are about 3 dozen pre-declared names like int and true. So, text functions. Names are not reserved, so you may use a handful of places. Declaration. A declaration names a program. This specifies var const type and func. We'll talk about variable type in chapter 3 and functions in chapter 5. Go programs. Go. Each one begins with a package declaration that says what package is what. Package declaration is followed by an import declaration. This is package level declarations of types, variables, constants, blah blah blah. Okay, so we mentioned the package, we mentioned what to import it from, and then a couple constants, blah 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 blah, which is what we had earlier in the VS Code implementation of the constant, because we had a constant declared duplicate string start. Okay, so the constant declaring f, function declaring f, optional search all. Let's see. So The name of each packet is visible not only throughout source code and source file that contains it, but throughout all files of the package. By contrast, local declarations are visible only within the functions which they are declaring, perhaps only within a small part of it. Yeah, this is talking about the scope of variables in functions, or in your program. A function declaration has a name, list of parameters, variables, and values provided by the function calling optional list of results. The function body contains a statement. If the result is omitted, the function is not returning things. Different number of functions that already. Function of tuple encapsulates so. So we have a function here which encapsulates the conversion of Fahrenheit to F2 Fahrenheit to Celsius. Yeah. So variables. var declares and creates a variable of a particular type, attaches a name to it, and sets its initial value. Each declaration has a variable name type expression. Any time it will be omitted, but not either the type or the equal expression may be omitted, not both. If type is omitted, I said omitted. If type is omitted, it is determined by the initializer of the expression. If the expression is omitted, the initial value is a zero value for the type, which is zero the number, false for Boolean, and empty string for strings, nil for interface, and a reference type. Oh, a nil for interfaces and reference types. So, okay. Zero value of an aggregate type. Zero variable. This is simplified code and observations. Let's go get conditions without string. For example, string. Var string, print s, and print out an empty string instead of giving a null pointer exception, which is what Java would do. Print So BFS Boolean float string initialize. Okay, short variable declaration. So this is regular variable declaration. So we have a variable, a name for that variable, the type, and then what the assignment is for the expression. And then we have a shorthand notation for the variable declaration. Within a function, an alternate form called a short variable declaration may be used to declare and initialize local variables. Use the form name, expression, and type of the name determined by a type, expression, and thereof. Main short variable declaration in the lysajuice function. So this is the short variable declaration. In the short variable declaration, we have this colon equal. And then brevity visibility, short variable declaration used to declare the initialize. To declare and initialize the majority of local variables. The right declaration tends to be reserved for local variables that need an explicit type that differ from the one of the initializer expression of the one from the same type. The value later initialize is initial is important. So for float name okay, as with the right declaration model declaration model should be keep in mind multiple Keep in mind that :I is a declaration, whereas equal is an assignment. There is a difference between the declaration and the assignment. So this is different. F is equal is declared as a no. It's 1 point. A short variable declaration. If some of them were already declared in the same lexical block, then the short variable there's both in error. The second declares out, but only assigns a value to the existing error variable. Okay, a short variable declaration must declare at least one variable, however. I don't get why we would need a short variable declaration must declare at least one new variable. However, this code will not compile. So if we have okay, so it looks like we can't redeclare two of the same variables. There has to be at least one. There has to be at least one of them that's different when we're initializing them. So the fix to use an ordinary assignment for So now we're getting to pointers, which is the familiar syntax with C. So a variable is a piece of storage containing a value. A variable is created by a declaration or identified by a name, such as x, and many variables are identified only by an expression like x of I or x.f. All these expressions are read. A pointer is the address of a variable. A pointer is just a location at which the value is stored. Not every value has an address, but every variable does. Okay. With a pointer, we can read or update the value of a variable indirectly, without using or even knowing the name of the variable. Indeed, it has a name. Variable declared var int. The expression address of x yields a pointer to an integer variable. That is a value of type *int, which is a pronounced pointer to int. So ampersand is address, star is pointer. So the address of x yields a pointer, and *int yields a pointer to an integer variable. That is a value of type *, which is pronounced pointer to int. If this value is called p, we say p points to x, or equivalent p contains the address of x. The variable which p points to is written *p. The expression *p yields a value of that variable in an int. So since *p denotes a variable, it may also appear on the left-hand side. Basically, this is going over the pointer assignment, pointer and address assignment, which Golang allows us to do. So let's do a bit of that to see what exactly these address contain and how we assign them and how we modify them throughout. Let's just create a new. Yeah, we're not going to be using this, so let's just delete this for now. Now, let's say that we assign, let's follow what they did there in the book. We assign a variable to 1, we assign a second variable to the address of x, right? So remember, to go to the address, we use ampersand. And then if we change the value of p, right, so we dereference p, normally, since p is pointing to the same place as x, right, because it shares the address of x. I don't know why this is doing tab sizes. Use and don't use spaces. There's setting here. Preferences, settings. So what about space? Tabs. Use tab stuff. Let's just say that back here. So yeah, so we have two variables. One is x, which is an integer, and then the second, which is p, which is a pointer to an integer, which is assigned to the address of x. So we dereference p and then we assign that to 2. So now if we print 2, fmt.print line x, right? Since we are passing in, since we modified it using a pointer, if we execute it now, go run fetch.go. So even though we initialized it with 1, we modified the variable to we modified the variable at the address of p, we modify the variable which p points to, which is the address of x. So if we make this a bit more explicit, so we have here var x of type int is equal to 1, and then this would be, make this a bit more explicit, var p of type pointer to int is equal to the address of x, right? And now we dereference p, so we go into the address of p and then we assign that to 2, and then it's the same thing as what happened earlier. So we assign the pointer to and then that pointer also modifies this because they share the same address. Okay, so each component of a variable of aggregate type of field is struct or blah 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 is also a variable and thus has an address too. Variables are sometimes described as addressable values. Expressions that denote variables are the only expressions which address of operations may be applied. 0 value of a pointer of any type is nil. The test p does not equal nil is true if p points to a variable. Pointers are comparable. 2 pointers are equal if and only if they point to the same variable or both are nil. So x is equal to x. The address of x is equal to x. The address of x is not equal to the address of y. The address of x is not nil because it's 0. So if we instantiate x, right, var x of type int, it'll initialize it with 0, which is the reason why it's not nil. But if we have a pointer, var y of type pointer to an int, no semicolons and go, and then we decide to print it. Print y, substitute that with y. Go. So you see, it's nil even because the initial value of pointers are nil since they don't have an address. But x has an address, which points to the address of x contains the value 0 when it's initialized. That's why when we point to 0 with the other value, we're able to get that value updated. Okay, it is perfectly safe for a function to return the address of a local variable. For instance, in the code below, the local variable will be created by a particular call var p is equal to f. Function f returns an int. So int is equal to 1, return the address of each call, f returns a distinct value. F equal f. It's false because we're doing a new allocation of pointers. Because a pointer contains a new address of a variable, passing a pointer argument to a function makes it possible for a function to update a variable. For example, this function increments a variable. V is equal to 1, increment the address of v. Pipeline increment the address of v. Side effect, v is now 3. V is 3. Increments, what p points to does not change. Okay, so increment v is now 2. Yeah. I don't think that's intended function, but for example, this function increments a variable that has an argument that its argument points to return a new value of the variable, so that we use an expression. So we increment v, and then we would probably print v is 3. Yep. Each time we take the address of a variable or color, we create a new alias or other way of identifying the same variable. For example, star p is an alias for v. Pointer like aliasing. So it allows for us to access a variable without using its name. But this is a approach. To find all this thing, we have to know all its aliases. So I'm just pointers below, so I'll copy. Values are the reference type like slices, maps, channel, image, structure, arrays, interface, opportunities type pointers. Our key to flag package, which uses programs command line arguments to set values to certain. To illustrate this. To illustrate this variation on the earlier echo command to our no flags, -n causes echo to omit the trailing new line that would normally print it in -s. Sep causes it to separate the output argument by the content of the string set instead of the default space. Since it's the 4th version, the package is called echo 4. So we have a flag, the bool n. I don't really understand what this does. Yeah, let's just say that the new function. Another way to create a variable is to use a built-in new function. The expression new int creates an unnamed variable of type t, initializes it to 0 value of t, and returns its address, which is the nature of type star t. P of type int points to an unnamed int variable. Deeper line, blah blah blah. So we're pointing to an unnamed variable. A variable creates a new. Created with new is no different from an ordinary local variable whose address is taken, except that there's no need to invent a dummy name, so we just need new t. So yeah, these are just new ways of returning well, not new ways. This is just ways of returning the address instead of assigning it to a dummy variable that will be used afterwards. Two variables whose type carry no information is therefore size 0, such as struct may be, depending on implementation, out of the same address. Instructions are relatively rarely used because of the common unnamed variable that is struct, which since new not a keyword responsible to be found. Lifetime of variables. Lifetime of variables is the interval time during which it exists in a lifetime of average level variables. Whose entire execution. By contrast, local variables have dynamic lifetimes. A new instance is created, shiny declaration, is executed, and the variable lives until it becomes unreachable. At which point its storage may be recycled. Function parameters and the results of other variables. They are created each time their enclosing function is called. For example, in this excerpt by Lisa Juice program, for t assigned to 0, 0 t is less than cycle blah 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 t plus res, x assign it to this, y assign it to that. Variable t is created each time the for loop begins and created for each iteration. How does garbage collection know? The first story is much more detailed than the basic idea is that every packet of a variable. So there's garbage collect. They're basically mentioning that there's garbage collection to the variable declaration of our programs. Compiler may choose to allocate compiler may choose to allocate local variables on the heap or on the stack, but perhaps surprisingly, this choice is not determined by the var enumerated bar. X must be heap allocated because it's still reachable from a global variable after f has returned. Var global is equal to the address. Despite being declared as a local variable, we say x escapes from f. Conversely, when g returns the variable, y becomes unreachable and can be recycled. Since star y does not escape from g, it's safe for the compiler to allocate y on the stack, even though it was allocated with me in the case. Blah blah blah. Garbage collection is turned into something writing correct program. It does not relieve you from the burden of thinking about memory. You don't need to explicitly allocate free memory, but write a efficient program that will need to be aware of the lifetime of variables. For example, if you are necessary pointers to shorten the object, then along with the expression of global variable, blah blah blah. Okay, so basically, there's garbage collection go where if a address or a variable is not being used, it's going to be automatically collected in the garbage collection process. So we see a lot of this in higher level languages, stuff like Python, Java, etc. But lower level languages like C, you have to free whatever memory you allocate after you allocate it. So assignments. The value of a variable is updated by an assignment statement. Yeah, so this is equal. Each of the arithmetic times equal. So this one v plus plus v minus minus tuple. Okay, Another form of assignment is known as tuple, some other people out there. Allows for several variables to be assigned at once. All of the right-hand side expression are evaluated before any of the variables are updated, making this formula most useful of all variables appear on both sides of the assignment, as perhaps, for example, in swapping the values of these two variables. Let's see how much is left. Assignability, type declaration. Let's stop at assignability, and then we'll call it a day for Go. Okay, so xy equal was the what is this thing? So all of the right-hand side expressions are evaluated before any of the variables are updated, making this form the most useful when some of the variables appear on both sides of the assignment, as happens, for example, when swapping the value of two variables. So a of blah 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 when computing the GCD. Yeah. For y does not equal 0, xy equal, yeah, so this is fairly common algorithm question finding the GCD. So you assign x to y, and then you assign y to x mod y, and then you do that until y is not equal to 0. Until y is equal to 0. And then Fibonacci. Oh. X is equal to 0, 1 for I less than 0, I less than I. XY. Well, double assignments can also make sequence of trivial characters compact. As a matter of style, where two calls for questions. There are three operators that sometimes behave as well as type assertion, channel, map lookup, v, okay, okay, v, okay, t. Okay, so this is more advanced stuff. Assignability, assignment system are explicit. Assignment statements are an explicit form of assignment, but there are many places where return statement consists of the size return operand. Okay. Metals, assign it to an array of type string. Then this is the array implicitly assigns each element as if it had been written like this: 0, 1, 2, 3 element. The map, the channel is not blah blah blah. Assignment words. It's always legal. More generally, assignment is legal. Assignability. Okay. Whether two values would be compared with equal or identical, and compare must be assigned okay. Alright, I think this is a good place to stop at type declarations, and we'll call it a night. Thank you for watching. It's very, my eyes are very heavy. I know, and I'm feeling kind of sleepy, so gonna call it for now, and yeah, thanks for watching. Bye.